So let's talk about nomenclature for aldehydes and ketones in this PowerPoint. So the carbonyl group looks something like this, which is a C double bond O. And I think this might be our first time that we're actually studying carbonyl groups. So let's talk some of the properties of it as well. Okay, so C double bond O, looking at this carbon here, this is an AX3, which means that this is an sp2 hybridized carbon. Also, if it has a double bond, generally you can say it's easily sp2 hybridized. So it's sp2 hybridized, which means that it's a trigonal planar structure with a 120-degree bond angle. Okay, so that's the physical structure of this functional group itself. Then the other aspect about the carbonyl, which is what we will be dealing with in the reaction part, is the fact that the carbon of the carbonyl is a little bit positive and the oxygen is the negative, because of course oxygen is electronegative. So this is delta negative, this is delta positive. All right, so this is going to become important when we talk about reactions, as I said. So it's a polar group. But anyhow, okay, so we have aldehydes and ketones, and aldehydes have a hydrogen on one side of the carbonyl, whereas in case of ketones, you have alkyl groups on both sides. I consider the ketones as an internal group just for my classification purpose, and the aldehydes are terminal groups, so they'll be hanging out there. Now this R group here, in case of aldehydes, it can be hydrogen, okay, but one of them has to be hydrogen. That's it, okay, at least one of them. So looking at the nomenclature for the aldehydes, so first of all, there are going to be two nomenclatures as usual, the general nomenclature and the IUPAC nomenclature. In the case of the general nomenclature, we'll stick to just about 4 carbons, okay, in there. So, carbon 1, 2, 3, 4, but anyhow. And then for the IUPAC, it's a little bit simpler because now what you have to do is for any aldehyde, you have to end the name with al. Okay, so whatever alkane you have, remove the E and put in al there. All right, so it becomes a little bit easier. The other thing about aldehydes is that the aldehyde group will always take priority, which means that the aldehyde group is always numbered as the first carbon. Remember, aldehydes are the terminal group, so you can start numbering from there. So that's number 1 carbon. Also, the priority means that you have to end the name with that priority group. Okay, so which means aldehyde, which means al. Okay, you'll always be ending with al. So the general name, which I said will be only for 4 carbons, is just because some of these compounds have been around for such a long time that they got their general names. And especially for carbonyls, it's a little bit unusual because carbonyls follow the same kind of trend for nomenclature, okay, for the first 4 carbons. So we'll go through that, okay, over here. So I'll show you, for example, the first aldehyde, which is HCHO. So that is going to look like this. Right, so HCHO, and so this is called formaldehyde. The form part of this is the 1 carbon part, all right, and then the aldehyde, of course, is the aldehyde. IUPAC nomenclature is pretty straightforward because that's methanol, and so the meth coming from the 1 carbon, and then the al is the aldehyde. Now, usually nobody says methanol in labs because, again, we have general names, and the reason we have general names is because they are very common. So everybody calls it formaldehyde in the lab. Okay, so if you want to say methanol, you have to be very careful with your enunciations because methanol, right? So alcohols and aldehydes, very similar sounding, so you have to be very careful with this. So in any case, that was formaldehyde, and again, form stands for the 1 carbon. Now the next aldehyde is acetaldehyde. Now acetaldehyde stands for the 2 carbons that you will have there. Okay, so that's the acet, 2 carbons. So acetaldehyde, or the IUPAC is ethanol, okay, for this. So I think you get the idea, okay, of what I'm trying to convey to you. Propione is for 3 carbons. Propanal is the IUPAC, the butyraldehyde, and then that's butanal in IUPAC. Okay, so that's the 4 carbons that I was talking about. After that, we get into the nomenclature, which is the pentanal, hexanal, and so on and so forth. Okay, so but it's just for the first 4, and you will see that we will be using these prefixes for acids also and esters and all that. Okay, so you can't forget these because we have to use them again as we go on. Okay, so a little bit more examples over here for you. And so if it's a straightforward thing, like for example, this one, 3-methylpentanal, you know, makes perfect sense because here's the aldehyde, 1, 2, 3, third carbon has the methyl, and so 3-methylpentanal, that's all fine. If you have something of a cyclic nature, now in this case, the cyclic compound, you know, how do you name the aldehyde? So in this case, this is called carbaldehyde. Okay, so the CHO group is called carbaldehyde. And so this one is 2-cyclopentene. So 1, 2, so 2-cyclopentene carbaldehyde. Okay, or you can also call it cyclopentuene 1 carbaldehyde. This is the more latest. Okay, this is not the more latest. This is the latest nomenclature. Then here's benzaldehyde, which you have encountered before in aromatic compounds. But if you have an aldehyde and an acid, the acid takes precedence. And I know we haven't done acids yet, we will. But if you do have an acid and an aldehyde, then the acid takes precedence and the CHO group now becomes formal. And if you're wondering why I'm trying to confuse you, I don't know. Okay, so sometimes it's carbaldehyde, sometimes it's formal, but you know, usually whenever there is another functional group with higher priority, it's called formal. So here we go. Anyhow, so the formal benzoic acid, usually, you know, if I ask you to make something like this, I will just say make this compound. I probably won't give you the name for it, but anyhow, now you know the nomenclature also. And finally, if you have an aldehyde and a ketone in the same compound, aldehyde takes precedent. It's a terminal group, and the carbonyl for the ketone is called oxo. Okay, in those cases. So this one here, 1, 2, 3, 4, 5. So 5 carbons, pentanal. On the third one, there is a methyl, and then the fourth one, there is an oxo group. Okay, so simple nomenclature should be fine. Okay, some of these ones that might kind of give you a little pause, but take that pause, okay, and then do the nomenclature. Okay, ketones. Now in this case, you'll be ending in -one. In aldehyde, it was al. Here, it's going to be -one. Ketones generally do have higher priority over other functional groups, not with aldehydes though, but with other functional groups, they do. And by the way, I haven't really quite explained to you you know, why we do aldehydes and ketones together. They're very similar. I mean, I call them siblings in some ways because they behave the same way. So we do aldehydes and ketones together. There are just a couple or maybe 3 reactions, you know, that are different for both of them, or the way they are made is a little bit different, but otherwise they're done together. Okay, that's why we don't have 2 chapters for one for aldehyde, one for ketones. Okay, so we do them together. But still, naming ketones and naming aldehydes, aldehydes take priority, okay, for nomenclature. So here you'll end with -one if you just have the ketone in there. All right, and again, there are going to be some general names. So I've just given you the general names in italics so you can kind of realize that, okay, this is what it is. So ketone, let me explain some of the basic fundamentals to you, and the rest I know you will get. So here, this one is a 3 carbon, which is the smallest ketone possible because ketone is an internal group. So this one here for the IUPAC nomenclature, propane 2-one, 1, 2, 3 propane, and then 2 is in the second carbon is where you have the ketone. Now in case of propanone, there is no other place for the ketone to be except at 2. So sometimes feel like little redundant to write 2, but you know, what the heck, let's just go ahead and do it. The other common name for this is acetone. Now remember, acet was 2 carbon. So here are the 2 carbons, okay, one with the functional group and then another carbon attached to it. That's the acet group. And the last name possible for this is dimethyl ketone, in which what you do is you take the ketone as your center part, and then you name anything that's on either side of the keto group. Okay, so this is kind of like the easiest nomenclature, right? Dimethyl ketone. So you don't count the carbon with the keto group. That's already the keto group. Okay, anyhow. All right, going along. So this one here, now you have 4 carbons. So 1, 2, 3, 4. This is butanone. Now you do have to tell. In this case, you do because there's a methyl group also. But otherwise, you don't have to write butane 2-on because whether the ketone is here or here, without the methyl, it wouldn't matter. Okay, but we'll do that because here we have a methyl group. So 3-methyl butane 2-on, or the other nomenclature would be methyl isopropyl ketone. So methyl and then isopropyl ketone, and I have the nomenclature wrong here, so I will fix it later. Right now I don't feel like stopping, so the isopropyl should come first. Okay, alphabetical order. So I will fix it later. Okay, but remember you always have to name in alphabetical order. Okay, so isopropyl methyl ketone. Okay, so then here is another one, and hopefully you get the idea of the ketone. And here I'm finding another error. Oh my Lord. So here we go. Okay, a little bit of a dash there with the between the 3 and the on. Okay, over there again, I'm not stopping right now to fix it. I'll fix it later. So 2 bromo, 4 methyl, and then pentane, 3 on, and so on. Okay. If you have any other functional group, remember ketone takes priority, except with aldehydes. Okay, so here if you have an alcohol group, no worries, ketone takes priority, okay, for the alcohols. In cyclic compounds, again, you have to start the numbering from the keto group. Okay, so here is 3-bromo cyclohexanone. Now you don't really have to say 1 hexanone or hexanone 1-on because it's understood that you're starting your numbering from here. So 1 really here is going to be redundant. Okay, so do not number the ketone as 1 at all. It's understood. Then this one here is an acetophenone. We have done this before, or this can also be called the methylphenyl ketone. Again, ketone in the middle and then either groups, on both sides. That's going to be the methylphenyl ketone. And then here is benzophenone. Okay, so with 2 benzene rings on the ketone, it's called benzophenone. So keep it simple with the nomenclature. Don't make it complicated. So the physical properties of aldehydes and ketones are slightly polar in nature because of the carbonyl. So because of that, they have a little bit of higher boiling point. So I've given some here to you with 3 carbons, okay, just to compare. Butane here is of course 4, but butane is barely a liquid, okay, so it's butane is kind of borderline, okay, liquid and gas, so it's kind of liquefied gas, I don't know, anyway. So then here if you add 1 oxygen to the alkane group, so then it becomes ether. So now the boiling point's increasing because you have polarity, and then here is aldehyde and here is acetone. Okay, so you can see that the boiling points are increasing, and for alcohols you can see it's way high, which is understandable, right? Because alcohols have the hydrogen bonding, okay, in there. So this is the general trend. So if you're wondering, between aldehydes and ketones, which ones have the higher boiling point, I wouldn't worry so much because I don't think I will give you that much to compare, but you should know how aldehydes and ketones compare to alcohols and versus alkanes and so on, okay? But you can see that the carbonyl group is a lot more polar than an ether group, okay? For example, that's one thing you can take away from this comparison. And the other comparison you will always have is that the higher the molecular weight, then the higher the boiling point or melting point of any compound. Solubility, now only very small aldehydes and ketones will be soluble in water because of polarity, and that also really not that much. Like acetone is definitely soluble in water. Formaldehyde is soluble in water, but even with the second and with 4 carbons, the solubility starts decreasing. Okay, so not that much, but the small carbons compounds will be soluble in water. Just remember that the aldehyde H, that is not responsible for any kind of hydrogen bonding. Okay, hydrogen bonding is only when you have the hydrogen connected to the oxygen. Okay, so if you have a bond like this, then that's hydrogen bonding. Okay, this one is like this, so this is not hydrogen bonding. However, this oxygen is available in case there was another alcohol group somewhere. Now that can bond, like this to something else. That's a different kind of thing. All right, but otherwise the aldehyde group itself does not have any kind of hydrogen bonding, so don't use that as a factor. And then odor. So odor, yeah, oh my gosh, this is so amazing smells that aldehydes and ketones have. So they're used a lot actually as flavoring agents. We'll talk about that in the next slide, but they do have odor, some good, some bad, but usually good. And one of the things about all these odors that we need to understand is that odors can smell differently with concentration. So if you have something really highly concentrated, it may not smell very good. Okay, but in a very small amount it can smell really amazing. So that's something you have to kind of understand about odor. All right, so when we say that there is benzaldehyde, which is the smell of almonds, but almonds have a very, very low quantity of benzaldehyde. Okay, if you smell benzaldehyde in the lab, it's actually very bitter. Okay, and so you need very, very small amount in order to get the flavor of almonds, okay, in there. Okay, so the applications of aldehydes. Formaldehyde is one of the most common solvents. It's also used as a preservative, and I'm sorry, not as a solvent, as a preservative. And then it's also used as a polymer. Bakelite is extremely common as a polymer. Just in case for your general information, the billiards, the balls, billiards are actually made of bakelite. Initially, they used to be made of ivory, and you can imagine how bad that is, trying to get ivory just so that you can play a game, from elephants and all. So anyway, so they, stopped doing that. They stopped making the billiard balls with ivory, and they invented bakelite, and that was coming from formaldehyde. So thank God for that. We don't have to take any more tests from elephants. Then, of course, there are the smells, okay, that we have from aldehydes. And so here are some examples for you. Hexanal, the fresh cut grass, don't we love all that? I mean, it depends. Smell is a very personal thing. Something that I may really love, you may not really like, and vice versa. So, it's a personal thing. So I would never question anybody's smell, and hopefully neither will you. So here's vanillin smell. Here's the aldehyde group. Here's an alcohol group too. So vanillin is complicated. It's not just that it has aldehyde and that's why it's smelling. No, I mean, it has other functional groups too. Cinnamaldehyde has the aromatic, of course, in it, but also has the aldehyde. And cinnamon smell, oh my lord, we know cinnamon smell, right? And then, of course, benzaldehyde, we just talked about the fact that it is the smell of almonds. Okay, so very common kind of compounds for aldehydes. And then ketones also are extremely common in our lives. Acetone, of course, in the lab, we cannot live without acetone as a solvent. That there are a lot of terpenes. Terpenes are very, there are a class of compounds which are 5 carbons in length. 1, 2, 3, 4, 5, and so they are like, this one is made up of about 10 carbons, so there are 2 terpene groups in here, or I should say 2 isoprene groups. So isoprene, 2 isoprene groups makes 1 terpene, but it's a very special class of compounds, and so there are 2 terpenes that I've given to you over here, which are very wonderful smelling, camphor and carvone. Then there are also, you can find ketones in steroids, okay, which are found in us, of course, and so very common, okay, these kind of groups. And I have not even mentioned the sugars, okay, in here. So sugars also have aldehydes and ketones, so very common groups. And I think that's about it that we have for this one.